Welcome, everybody. We now start looking at change of variables formula for double and triple integrals. Before I do that, let's review the substitution rule or the change of variables formula that we have seen in Calculus 1. So in Calculus 1, we have seen the following substitution rule or change of variables formula. So if I have the integral from a to b of f of g of x times g prime of x dx, then notice that the integrand, so here the integrand has two factors. The first factor is a composition where f is the outside function and g is the inside function, and the second factor is the derivative of the inside. And if we substitute u for the inside g of x, and du, the differential of u, is equal to g prime of x dx, then we get this integral of f of u du, where f is the outside function here, and the limits of integration for u here is from c to d, where c is g of a and d is g of b. So notice that when x is a, we get g of a. When x is b, then we get g of b here for u. So those are the limits of integration for u. So this is the change of variable formula that we have seen in Calculus 1. Now I'm going to write this formula slightly differently. I'm going to start with the right hand side and then rewrite that in terms of the left hand side. So in other words, here's what I'm rewriting this equation here in the following way. So let's say we have the integral from a to b of f of x gx, and then we are going to substitute g of u for x, and if we do that, then the differential of x would be g prime of u du. So dx is g prime of u du, and then f of x is g of u. So if we substitute g of u for x, this is the integrand that we get. So notice that not only did we substitute g of u for x, we also have this extra factor g prime of u. And the limits of integration is from c to d, where g of c is a and g of d is b. In other words, c is g inverse of a and d is g inverse of b, given that the inverse of g is does exist. So here notice that so in this integral, the way I want you to think about this is that the function g of x, the function g of u, so let's say this is the ux plane, and the function g of u takes the interval from c to d onto the interval from a to b. So g, when we apply g to the interval from c to d, we get the interval from a to b. In other words, if I apply g inverse to the interval from a to b, then we'd be getting the interval from c to d. So basically, the interval from c to d is the inverse of g applied to the interval from a to b. So again, here we have this integral from a to b of f of x dx, and then we are substituting x with g of u. So we are changing the variable from x to u via some function g, and we are assuming that g has an inverse. Then the new integral that we are getting would be f of g of u multiplied with this extra factor g prime of u, and then we are integrating with respect to u. And the new limits of integration, that is the new interval over which we are integrating. So here we are integrating over the interval from a to b, and the new interval over which we are integrating is from c to d, where c to d is basically the inverse of g applied to the interval from a to b. That is applied to the original interval of integration. Okay, so this is the change of variables formula that I want you to focus on, and take a few minutes, pause the video, and think about this and let it sink in. What we're gonna get to in the next video is the following question. So now we are trying to do change of variables for double integrals, and so we have a function f of two variables x and y, and we are integrating f over some plane region R in the xy plane, and we are integrating with respect to x and y. Now, by writing dx dy, I don't mean to express any order of integration here. This is so I'm not trying to say we are integrating with respect to x first and then y here. This is just we are writing this because now that we are changing variables, it is important to know whether we are integrating with respect to x and y, or whether we are integrating with respect to two other variables, so u and v. So the question here is, if I have a integral like this, then I do a substitution. So that is, I substitute the variables x and y with the variables u and v via some function t, and we're going to assume that t has an inverse function. Then the question is, the new integral, what would be the region of integration for the new integral, and what would be the integrand for the new integral? So we will answer that question in the next video.